In this question, you've got to calculate the energy of a photon. So we're looking for something with E in it. I'll write that down. Some kind of formula with E in it. And what we're given is the wavelength up here. So then we're looking for something with maybe lambda in it. Lambda is wavelength. It's looks like this. Looks like a guy holding up a little crowbar. There you go. Okay, so these are the things we're looking for, and we need to find a formula with both of those. Now, there's not immediately a formula with both of those. Okay, you can learn off combined formula, but these are the two separate ones. There's E, the energy in a photon is equal to H, which is Planck's constant, times F, and F is the frequency. Now, there's also a formula which is something is equal to F lambda. And that something is either the speed of a wave or it can be the speed of light. Either will do. Okay, so you can either write in V, the velocity of wave. In this case, I'm going to write in C, the speed of light, because it's more relevant because we're talking about photons. Okay, now that we've got all the formula we need, we can kind of begin the question. The problem I have immediately here is I can see I've got the energy over here, so I want to choose that formula, but the problem is as well I've got the wavelength over there. So what we need to do is take these two equations and kind of combine them into one like mega equation in here. Okay, so what I'm going to do is I'm going to rearrange this guy into a form that he'll kind of fit inside that guy. So I need to, yeah, I'll tell you what, I'll slot it in for the F. So I'll get F by itself in this guy, and then I'll put it in for F. Okay, so I need to rearrange this. Let's do it. What I'm going to do is I'm going to, yeah, why don't I divide both sides by lambda, and what that'll do is it'll move this guy over. Okay, so if I divide, what? I just took his crowbar, but I want to take his hand as well. There we go. So now I've got C over lambda equals F. So now that I know that this stuff here is F, I'm going to put that in for F. Okay? So all I'll do is I'll just get this lad here. Bye-bye. And I'm just dragging him in. No. Come on. Come on. Yes. Get in there. Okay, so that's a formula now I can use to finish the question, because now I've got both wavelength and energy in the same equation, and I can figure this stuff out. Alright, so let's substitute in the values. That is equal to H, which is Planck's constant. Okay, Planck's constant is written down on the paper. Here's a picture I drew of Max Planck. There's a constant, so let me just draw that down. It is 6.626 times 10 to the minus 34. So that's 0.0034 zeros. And yeah, okay, wow. I'm not gonna put the unit just because it's just horrendous looking. Okay, that so that is our H done there. Okay, so then I need to put in C. C is the speed of light. C is, well, actually you can kind of just learn this off, but it's also at the front of your paper. It's 3 times 10 to the 8. If you get it from the front of the paper, sometimes they have it to a bit more decimal places, like 2.998 or something like that. Okay, I'll just for the moment. Okay, and then I divide all that by lambda, this guy here. So then I get my 709 and I put that down there. I'm going to just keep it in red for wavelength, because actually 709 nanometers is the color red. 500 is about green. N for nano, N for 9, that's nanometers. So 10 to the minus 9 meters. Okay, and there we go. So I'm going to bang all that into the calculator, and you should get about 2.8 times 10 to the minus 19 joules. Don't forget those units. You lose marks for units. The marks were as follows. You got 3 for E equals HF. You got another 3 for C equals F lambda. And when you put it all together and you get the answer there, that also got you 3. So 9 in total.